So in this video today we will be talking about the 11th standard 8th unit heat and thermodynamics. Okay. So the 8.1 heat and temperature. Temperature and heat plays a very important role in everyday life. All species can function properly except all this theory part. Let's see important topic. The meaning of heat. When an object at a higher temperature is placed in contact with another object at lower temperature, there will be a spontaneous flow of energy from an object at a higher temperature to the one at lower temperature. This is called heat. Okay, so there is an object, say for example, okay, object 1. Okay, there is another object 2. Okay, object 2. Okay, so say for example the temperature of this is, say for example, 120 degree Celsius. Okay, 120 degree Celsius. Say the temperature of this is, say 30 degree Celsius. Okay, 30 degree Celsius. Okay, now when we bring this object 1 near the object 2, okay, we are bringing this near the object 1. Okay, when this object 1 is brought near object 2, okay, we are bringing this here. Now when we bring this here, naturally what happens, the energy transfer, spontaneous flow of energy, this energy transfer takes place from object 1 to object 2. So this 120 degree Celsius, okay, the energy from this 120 degree Celsius flows into object 2, and naturally this temperature, which is 30 degree Celsius, now will increase to around 60 degree Celsius, around 60 degree 55 degree Celsius, making it almost equal. Okay, so this flow of energy, see, read this once again. When a body at higher temperature is placed in contact with, so here we are making contact, okay, here at this place we are making contact with another object at a lower temperature, that is object 2, there will be a flow of energy from object at a higher temperature to the one at lower temperature. This energy is called heat. This process of energy transfer from a higher temperature object to lower temperature object is called heating. Due to the flow of heat, sometimes the temperature of the body will increase or sometimes it may not increase. When you rub your hands against each other, the temperature of the hand increases. You have done some work on your hands by rubbing. The temperature of the hand increases due to the work. Okay, the temperature of the hands increases due to the work. Now if you place your hands on the chin, the temperature of the chin increases. This is because the hands at a higher temperature than the chin. In the above example, the temperature of the hand is increased due to work and the temperature of the chin is increased due to the heat transfer from the hands and the chin. By doing the work on the system, the temperature in the system will increase. Okay, by doing work on the system, okay, remember this is the keyword. By doing the work on the system, the temperature in the system will increase and sometimes may not. Like heat, work is also not a quantity, and through the work energy is transferred to the system. So we cannot use the word the object contains more work or less work. Either the system can transfer energy to the surroundings by doing work on the surroundings, or surrounding may transfer energy to the system by doing work on the system. For the transfer of energy, okay, now either the system can transfer energy to the surroundings. Okay, for example, consider when they are talking the word system. Okay, suppose a steel object, say at 500 degrees Celsius. Okay, consider a steel object or something which is 500 degrees Celsius. This transfers energy to the surroundings. Okay, when we keep a very hot object on the open space, naturally the heat energy from this object will get transferred to the surroundings, right? So that's what it is saying, that can transfer energy to the surroundings by doing some work. Some energy is, some work is going on within. We assume that it's the imaginary system. Okay, some work is going within the system, and heat of 500 degrees Celsius is generated and it dissipates the energy to the surroundings. Okay, this is one. Or the second case is, okay, the surroundings may transfer energy to the system by doing some work on the system. Say for example, we have some object. So the outer the surroundings is very hot. Say for example, we are in a desert like situation, very hot. We are having some steel plate or something like that, okay, which is at a normal temperature. When we are taking it to outer temperature and keeping it outside, so the surroundings temperature, say in the desert, maybe around 50 degrees Celsius. So naturally the heat gets transferred from the surroundings to the objects, okay. So naturally, even when we place a car in a very hot condition, what will happen? Heat gets transferred from the surroundings to the car or any other object, and the temperature increases, okay. The surroundings may transfer energy to the system by doing work on the system. So for the transfer of energy from one body to another body through the process of work, there need to be at different temperatures. Yes. Say for example, we already seen two objects. For the energy transfer to takes place from object 1 to object 2, or from object 2 to object 1, or vice versa, that these objects has to be at different temperatures. If both are at 60 degrees Celsius, so if for example object 1 is at 60 degrees Celsius and object 2 is also at 60 degrees Celsius, then no energy transfer will take place. Only if one is at a higher temperature and one is at a lower temperature, only then the energy transfer takes place, okay. What is the meaning of temperature? The temperature is the degree of hotness or coldness of your body. Previously what we have seen is heat. Now what we are seeing is temperature, okay. The hotter the body, higher is its temperature. The temperature will determine the direction of heat flow when two bodies are in thermal contact, okay. See, remember this word. Temperature is the degree of hotness or coldness of a body. Hotter the body, higher is temperature. So say for example, okay, we have in the heat, the energy transfer takes place from one place to another, okay, or from one body to another, or from body to the surroundings, or system to surroundings. Whereas in the case of temperature, say for example, we have a steel rod. Say for example, we are heating it here, okay. We say for example, we are heating it here, okay. We are heating it here. Here the temperature is 100 degrees Celsius. So here then it becomes 80 degrees Celsius here. Then it becomes 70 degrees Celsius here, okay. Then it becomes 60 degrees Celsius, 50 degrees Celsius, okay. So when we are measuring the temperature, say for example at this point, okay, we are measuring the temperature at this point, we are measuring the temperature at this point, we are measuring the temperature at this point. So at that particular instant, okay, the temperature is the degree of hotness, okay, remember this word, degree is the keyword, degree of hotness of a body, okay. So what is the degree of hotness here? 100 degrees Celsius. What is the degree of hotness here? 80 degrees Celsius. What is the degree of hotness here? 70 degrees Celsius. What is the degree of hotness here? 50 degrees Celsius. So at this point, temperature talks about the hotness or temperature or the condition at a particular instant or particular point, one point, okay. Whereas heat talks about flow of energy, okay. That is the difference, okay. Heat talks about flow of energy, whereas temperature talks about the condition of heat, okay, at a particular instant or one point. There is no flow of heat takes place. The temperature will determine but the temperature will determine the direction of heat flow when two bodies are in thermal contact, right. So this is one, the temperature will determine the direction. So for example, we are heating it here, this is very cold, okay. So naturally heat flows what? From this direction to this direction, right. So that's what it says, the temperature will determine the direction of heat flow. So here it is at a higher temperature, say 100 degrees Celsius, okay. So here it is at a lower degree Celsius, say at room temperature, say 25 degree Celsius. So this difference in temperature, okay, determines the direction of heat flow. So at a particular instant it is 100 degrees Celsius, 80 degrees Celsius extra, but this flow of energy from this point, okay, from this point to this point is called heat, okay. The SI unit of temperature is Kelvin, okay. So in our day-to-day applications we normally use Celsius and Fahrenheit scale oscilloscope. Temperature is measured with a thermometer. Okay, so all of you must have studied this. Temperature is measured with a thermometer. The conversion from Celsius to Fahrenheit, Fahrenheit to Kelvin, all these things which you must have studied in your younger classes, and you can just go through it. Okay, thermal properties of matter. Boyle's law. For a given gas at low pressure, okay, kept in a container of volume V, experiments reveal the following. See, remember this condition. This Boyle's law, Charles law, and ideal gas have been formed for the condition. For a given gas at a low pressure kept in a container of volume V. Okay, so we have a container. Okay, we have a container which is full of gas. Okay, which is full of gas at low pressure. And it has some volume. Okay, it has some volume. It occupies some space and it has a volume. And the experiments conducted reveal the following information. When a gas, okay, this is gas. Okay, this is gas. When a gas is kept at constant temperature, the pressure of the gas is inversely proportional to volume. Okay. So what this means is, when the gas is kept at constant temperature, so say for example we are heating it here. Okay, we are heating it here. Okay, so the temperature inside is, say for example we are keeping it at 80 degrees Celsius. Okay, the temperature is constant. We are not increasing the temperature, we are just maintaining the temperature to 80 degrees Celsius. Okay, when the gas is kept at constant temperature, the pressure of the gas is inversely proportional to volume. So what is the pressure? Is inversely proportional. That is, the meaning of this is, when pressure increases, volume decreases. Okay, that is called inversely proportional. When volume increases, pressure decreases. See, that is the meaning of this. Pressure is inversely proportional to volume. So when pressure increases or pressure decreases, what happens to volume? See, volume decreases, volume increases. Okay, so that is this situation for inversely proportional. This was discovered by Robert Boyle, and is known as Boyle's law. So what this means is, say for example we have this condition, we have a container, we have a gas maintained at 80 degrees Celsius. Say for first we will take the example, when the volume decreases. Say for example we have a box here, when the volume, for example, okay, we will change the color. Now we have a volume. Okay, now the volume is here, and this is the first condition. When this volume is brought down and the volume gets decreased. Okay, when the volume gets decreased from the 0.1, volume gets decreased from 0.1 to 0.2, what will happen? This gas will be compressed. Okay, the gas which is occupying more space will get compressed. Okay, what will happen when it gets compressed? The pressure is increased. So when the volume gets decreased, the pressure of the within this container increases. Okay, second condition, when the volume increases, V increases, pressure decreases. We have this container. Okay, now what will happen? The pressure P3, let's keep this as P3. Now we are increasing, this is a box or lid. Okay, now we are taking this lid to here at this point, we are moving this lid to this point. Okay, from here we are taking this to 0.3. Now what will happen? This gas within this container will have more space to move about. Okay, this more space to move about. So naturally what will happen? The pressure gets decreased. Okay, so when the volume increases, the pressure decreases. Okay, pressure of gas inside this container gets decreased. That's what Robert Boyle says, or Boyle's law says. Now I will see the next condition. When the gas is kept at constant pressure, okay, when the gas is kept at constant pressure, the volume of the gas is directly proportional to the temperature. When we are saying directly proportional, what will happen? When the volume increases, okay, temperature also increases. When the volume increases, temperature also increases. When the volume decreases, temperature also decrease. So we will see this condition. When the gas is kept at constant pressure, so how can we maintain the constant pressure? Under the two conditions. Say for example, when the volume increases, okay, when the volume increases, say for example, we are heating this container and it is 80 degrees Celsius. Suppose this increases to what? 90 degrees Celsius. Okay, we keep increasing and the temperature becomes 90 degrees Celsius. But when the temperature becomes 90 degrees Celsius, what will happen to the pressure? Definitely pressure will increase. Okay, we are having the container at P. Okay, we are having this container at P, this point P. Okay, we are having this container at here at this point. Okay, there is gas inside. We are having this container lid. This is the lid which is closed, which closes this gas container. Okay, now we are heating it here. We are heating the gas here. We are heating the gas here. Okay, we are heating the gas here. Now the gas is kept at constant. We are heating the gas. Now the temperature increases from 80 degrees Celsius to 90 degrees Celsius. But what is the condition here? We have to keep the pressure constant. Okay, that is the condition here. The condition is constant pressure. The constant pressure. So when the condition, when the pressure has to be maintained constant, so what will happen? What should we do not to maintain the pressure constant? We have to slightly increase the volume, right? We have to slightly increase the volume in order to maintain this pressure constant, because once the temperature increases, what will happen? The molecules or gas molecules inside this container will get very hot, and there will be random movement of the molecules. Okay, so the pressure will build up. So the pressure increases as the temperature increases. So in order to maintain this same pressure, for example, initial condition, the pressure is, say for example, 2 bar. Okay, say for example, initial pressure is 2 bar. So as the temperature increases, the pressure will increase to, say for example, 3 bar. Okay, 3 bar. But we are supposed to maintain the pressure at 2 bar. So what do we have to do? We have to move this lid upwards. We have to move this lid upwards slightly and keep it here. Okay, we have to keep the lid here so that these gas molecules will have more space to move about, and the pressure is reduced from 3 bar to 2 bar. Okay, pressure is again reduced from 3 bar to 2 bar so that we can maintain the pressure constant. Okay, so this is the condition for increasing the temperature. Under this condition, when the temperature, so what will happen? So the temperature increases. That is, we are heating this container, so the temperature increases. So what will happen? Volume is increased because we have to maintain the pressure constant. That is one condition. Similarly, same condition. Say for example, we are not heating anything. So and this container which has some gas, which is initially at 80 degrees Celsius, will come down to 60 degrees Celsius if we are not heating. Okay, if we are not heating it. So what will happen? Naturally, the temperature will decrease if we are not heating. So when the temperature increases, but we have to maintain the pressure. So the pressure will get reduced from 2 bar to 1 bar. But what is our objective? We have to maintain the pressure at 2 bar. So what will happen? So what should we do? We have to compress this container. Okay, see this container, which is here at this point, has to be brought down and kept this lid. Okay, lid has to be brought downwards and closed here, so that all the gases will get compressed and the pressure is maintained. Okay, since we are not heating, so we are not heating here under this condition. Okay, that is the temperature gets decreased after some time since we are not heating it. So I hope you understood these two Boyle's law conditions. Okay friends, I hope you must have understood the video. So if you have any doubts or comments, you can you need not hesitate, you can put it in the comment section. I will be ready to clarify your doubts. And those, I thank all those who are subscribed. Those who are not subscribed, kindly subscribe and share it with your friends. Thank you friends, we will see in the next video. Okay, thank you.